This is video 2 for CS 1124. Last time we started talking about OOP and just the time together. There we go. I'll put OOP on the board because we're still talking about OOP. Some more general, important, you know what? Everything is important until further notice. So if I say, here's the next thing, then it's important. Oh my, this is extremely important. Inheritance. Isn't it though? Especially if you got really rich folks. Inheritance, I don't even want to try to write a definition of that. I'm going to give a description instead. Description. A child, and that is the term to choose, a child object type. Object type is a clunky phrase to use. There is a word for that, or class, C-L-A-S-S. And that is, oh my goodness, that is such an overused word in computer science. In this particular context, it really just means sort of classification. I see a class of expired canned vegetables on the shelves in front of me. I see a class of desk lamps surrounding me, shining light in my face. So a child object type or a class of objects can inherit, keyword here, can't yell everything, but I'll double underline that, can inherit from a parent class. Comma, because that much of it is just introducing terms that is absolutely not enlightening at all. Meaning, here's the meaning. Meaning that the child object, abbreviate OBJ for object, meaning that the child object gets everything, all of the attributes and methods from the parent. I'll keep underlining those. The child object gets all the attributes and methods from the parent for free. Don't even have to pay taxes on it. And then it can have ... And then the child, it can have its own additional attributes and methods. Then the child can have its own additional, ADD apostrophe L, its own additional attributes and methods. Attributes and methods. Now you can play that back, but this is so important. For emphasis, I'm going to read it back. Inheritance. Here's the whole idea behind inheritance. A child object type, or a class as it's also known, can inherit from a parent class, meaning that a child object gets all the attributes and methods from the parent class for free. Then the child can have its own additional attributes and methods. Here's an example. We might have a class called animal, A-N-I-M-A-L. That's a whole collection of objects, a huge collection of objects. Worms and whales and donkeys and all that stuff. Those are all animals. Why would we even want to have an animal class which is so general? Well, I'll get into this later, but we can group all the stuff that all animals have in common and make that part of the animal class, and then have more specific types of classes that inherit from that. For example, now I'm drawing this arrow very strange. It looks like a white arrowhead. I'll explain in just a second. Fish. This is an animal. You knew it was coming. I might as well break the seal on it. Here it is. Dog. Dog is also an animal. The white arrowhead with an arrow. What that means, first color switch of the new semester, that's read ISA. I-S-A. Fish is a animal. A dog is a animal. Doesn't sound grammatically correct. I guess it should be an is-an arrow. But that's read is and why the white arrowhead? You know what? Over here to the side, I'll put UML, Unified Modeling Language. Let's answer this question again. How important is object-oriented programming? It is so important. It has its very own picture drawing language, where you draw pictures to design your code to describe how the different classes that have to be implemented with Python or C++ or Java or Swift or whatever language you're working in is language independent. UML is language independent, meaning you can implement it in anything. But it describes the rules for drawing pictures to design your code. Isn't that wild? A whole picture drawing computer language. This describes the case where dog inherits from animal and fish objects inherit from animal. And we can get more specific. That doesn't have to be just one layer of inheritance. I could have, what's a short dog kind? Pug, there we go. Pug. And MI address, mutt. That's a more specific type of animal, which is also a more specific type of dog. And wait, there's more. Beneath this, I'm going to stop it at this level. Beneath this, we could have specific mutt objects. Each of these, they're object types, that's true, but we might not have any specific objects that are, for example, nothing but an animal. They're not a more specific type of animal. Nothing but a dog. There's not a more specific type of dog. Down here, Leo and Trout. Not two troublemakers, but they're lovable. You will hear from them sometime through this semester. That's almost a guarantee. But what this says, what this picture is trying to tell us, at this point, perhaps in a mysterious way, is that Leo is a mutt. And in addition to that, a mutt is a dog. And in addition to that, a dog is an animal. Why would we arrange it that way? Well, let me see if I can justify this with a more example. See if this red is legible. Animals. What do all animals have in common? Well, an attribute they might have, I don't know, this is kind of morbid, it's the first thing that came to mind. They have a lifespan. That says lifespan. I hope you can read it. An animal. We'll assume that an animal is born and bless their hearts, eventually the animal is going to die, so they have a lifespan. Now, this does not mean that all, holy moly, this does not mean that all animals have the same lifespan, 10 years and that's it, no matter what kind you are. All it means is that everything that is an animal has a lifespan attribute, maybe an average lifespan attribute. Now, we group all that together up there, all the things that all animals have in common. Here we have a fish. What might a fish have beyond just what a regular animal has? Well, yeah, I should have thought about this before. I'm going to put a Boolean value, one of those true-false things. Salt water? Do you like salty water or fresh water? We're going to claim that that's not really a property we need to know about dogs, whether they prefer salty water or fresh water, but it's a pretty important attribute of fish. See where we're going here? And over here, what might a dog have that not every animal has? Well, an attribute that might be part of the dog class of objects might be bark volume, camel cased. Somewhere between 0 and 100 decibels. So we might have a bark volume for dog, but I'm going to go out on a limb and say it doesn't make any sense to have a bark volume property for fish. Just vice versa. Same thing as it didn't make any sense to have salty or fresh water for dogs. Almost as if on cue. What does a mutt have that a dog doesn't have? We'll say a mutt has a backstory that we might not care about with other full-blooded breeds. Backstory. And I could do this for every single one of these things. List attributes. What does trout have that a mutt doesn't have? Well, all things that are specific to trout. Trout has, he has a collar color. Actually, I'm not going to put that there because maybe all mutts have collar colors. But I think this is enough for me to try to make my point. If we focus on just the red stuff, just the attributes that I've listed here. Why would we even do this? Why don't we just take all the different properties, all the different things they can do, fetch, that might be a method for the dog object. We're telling the dog to go fetch something. Make a noise, bark. That could be a method for the dog object. So we've got methods and attributes and so forth that apply to dogs, but not all animals. The reason we group it like this is because we're trying to save ourselves some work. That's always a good thing, isn't it? Less work to do. Because if we say, well, trout, trout is a mutt, so trout gets all the properties and methods that a mutt, anything a mutt can do, trout can do. That's one way to phrase it. You know what? Anything that a dog can do, a mutt can do. Because mutts and pugs and collies and all the other kind of dogs, they all inherit from dog. So we end up not having to replicate all that set of attributes and methods for every single kind of thing we might have for at the bottom level for each one of our objects. We gather all the things they have in common, put that in a parent class, and then just in our code, as we'll find out when we finally get to it, we'll just say, you know what? I want a pug to have everything a dog can do, all the methods and attributes. So I'm just going to, in my Python code, say pug is a dog. And it inherits it all for free. Where does dog get its stuff? Like the lifespan and maybe the breathing rate. I don't know of a lot of generic animal things that are not more specific. But we'll say lifespan is one of the attributes. The breathing rate, that's one of the attributes and all that stuff. If I say that dog is an animal, then a dog gets all that stuff for free. So this is showing us really where we can cut corners and not have to put all of the attributes and all of the methods down here in one particular Leo variable. Leo gets all the stuff on the way up its family tree for free. And you probably already noticed this pattern, but I'll point it out. Excuse me if I'm insulting your intelligence. As we move down this inheritance chart, we get more and more specific. As we move up the inheritance chart, we get more and more generic. Up here, animal would be called a base class. It could even be called an abstract base class. It's possible to define things as abstract base classes, which means you're not even allowed to have objects of that type. You're not allowed to have something that's an object of type animal unless you're more specific about it. So we've got the base class. I'm going to label these. Another color switch. Animal, for this example, is a base class, meaning it's going to be somebody's parent. And fish is an example of a derived class. We derived, D-E-R-I-V-E-D, we derived fish from animal in the sense that we're just going to say, okay, a fish is an animal, so anything an animal's got, anything an animal knows how to do, a fish also knows how to do. So we better be careful not to put anything in our animal class like walking speed or something like that that would be more specific to a different kind of animal, because fish is not going to have a walking speed unless we're going to allow 0. They're going to have a 0 walking speed value. I guess that would work.